Hi everyone. Now we are going to see about the hashing data structure. Here in this representation, we are going to see the six topics. Is nothing but hashing and its data structures. And the second one, what are the common hash functions are there, and how do you implement only the division method, and what is collision in hashing, and as a fifth topic is nothing but how do you handle the collision occurs in a hashing mechanism, and finally what are the collision avoidance techniques, and especially what is rehashing, and what is load factor we will see, and how to make it an efficient load factor by the help of rehashing technique to avoid the collisions. Okay, first we see the definition of hashing mechanism, and what are the data structures are used to hashing techniques, that is where we have to apply the hashing technology. Yes, the hashing is a technique which is used to following the data structure for the fast and efficient storage, retrieval and manipulation data. Okay, so hashing technique is used to store and access the data in fast manner. For that purpose, the hashing technique is used, where the following data structures are used to store the data by applying the hashing technique are nothing but hash tables, where the informations are stored, and one of the field of hash table information will be taken for applying the hash technique. Similarly, the next data structure is nothing but hash sets, where all the informations are stored in the table only, but the data will be in unique manner. The third one is nothing but the memory, that is the primary memory. The fastest memory is known as cache, in which the hashing technique is applied to fast look up the data while processor is inactive. The last one, for the indexing purposes of the data or larger informations are stored in secondary storage devices, so that we can identify the data or information stored into the secondary devices by the help of indexing. Those indexing data is stored in a way by applying the hashing technology. Okay, then how do you apply the hashing technology? Eh, there are a number of hash functions out there which are used to find out the memory locations by applying the hashing technologies by the help of the hash functions. Okay, so commonly used hash functions given here, a very simplest mathematical concepts used here. Okay, so the first method is nothing but division method, in which the key is nothing but one of the field in the information which are going to be stored into a hash data structure. That field is known as key, that is taken and which is divided by a numerical value. That numerical value may be the memory locations, that is the size of the hash table. Okay, so the key value is divided by the table size, and the remainder of this division is taken as a hash value in which the data is stored. So that is the one of the very simplest, fastest method. But here the collision may occur. But so that we move on to the next and next methods according to the requirements of data to be hashed. So the second one is nothing but multiplication method, where the field as a key will be taken and multiplied a strong constant number, and again that is divided by a table size in which the remainder is taken. So the difference between the first and second one is nothing but before doing the modulo operation, the key value is multiplied by a strong constant value, so that the hash function is an efficient one. The clustering or collisions will be avoided. The next method is nothing but mid-square method. In this also, the key value from the information is taken, where always the key value should be in unique value. Such a key value is taken, that key value is powered up by 2, and the powered value from that a middle level of digits are collected, those digits framed as a hash value. So here extracting the middle value is the main functions. Okay, the next method is nothing but folding method. Here, wherever the hash key value is very larger numerical value, in that scenario the folding method is applied, where we have to shorten the field to broad the hash key value. In that place, the larger key value is divided into several parts, and each and every part adds on them together. That the final added value is taken as the hash key. Okay, the next method is nothing but digit extraction method, where the key value is taken, and from that a specific position number digits will be taken to find out the hash value. Okay, so these are all the methods used to compute the hash value. The next topic, how to implement the division method, which is a very simplest. As already told, the key value is a unique in the data information stored in the storage locations. That unique value is taken as a key value which is divided by a numerical value, and as a solution there will be a quotient and the remainder. The remainder part will be taken as a hash key into that location. The data, whole data related to that key will be stored. So that is the division method. Okay. As an example, now we will see. First, let us assume there is a table with 8 memory locations, which is referred as slots. That is, the table size is 8. Then, how do you do the division method and store the information? So now we are having the informations, totally 5 informations. From that the keys are retrieved is nothing but the 36, 18, 72, 43 and 6. They are key value of the informations to be stored into the memory area. So how do you compute the hashing function for this key value and find out the exact location to store this data? Is nothing but, now we'll see this example by the help of a table slots. So now we are going to store these informations, that is the key values along with the informations will be there. Those will be stored in each and every slot. So in which slot we have to store will be fine by the help of the division method. So here the n is nothing but 8. The key values are nothing but 36, 18, 72, 46, and apply the key 36 modulo 8. What is the remainder is taken as the key value, that is memory location, and so on. We'll see in detail. The first data is nothing but 36, which is divided by 8. That is the table size from 0 to 7. Then how many 8s are there? 4 8s are there. The remainder is 4. Okay, the quotient is 4 and the remainder is 4. So that the fourth location of this table, available table, is identified as the storage area to store the first value, so that which is stored here. Then you take the second value and divide it by 8. How many 8s are there? 2 8s are there, and the remainder is 2. So go to the second position of this table and store this information along with this key 18, and go to the next value 72, in which how many 8s are there? 9 8s are there, which is equal to 72. So 9 is quotient, 0 is remainder. So that the 0 position location is used to store this information regarding the key 72, and so on. So this is the division method to find out the hashing code, to which the hash code you are going to form, and the hash code is used as the index value of that hash table into which the informations will be stored. Okay. The next topic is collision in hashing. By the help of any one of the hash functions, if we are going to store the informations, there may be two keys, that is the function applied on two values will be given the same output, that is the same modulo value, remainder value. That is known as data conflict or collision in hashing. Okay, so once again you see the definition is nothing but when two different information keys are given as input into the hash function, and then that function produce the same hash code as the hash table index, then it will lead to the conflict or inconsistent of the data to be stored into the same location. More than one data to be stored into a single location definitely will lead to the conflict. That is known as collision in a hashing technique. Okay. So how the collision occurs, we'll see by an example. Let us try to insert the another key from the previous table. Here totally 5 data are stored, there is no collision occur. Once again, one more data we are going to insert here, means what will happen. So the same hash function to be applied here, the 7, 13, 15, 24, 23, and 28 to be inserted into the table. Its size is nothing but 7, where the same division function we are going to apply, and the modulo value will be taken to identify its location, so that the first value is taken and the table says 7 is used as a denominator, and its remainder is nothing but there are 1 7 into that 7, so that the remainder is 0. So we place the first value into the 0th position. Similarly, in the 13 only 1 7 and 6 is the remainder of the function, division function. So at the sixth location, the second value is stored. Similarly, the 15 is stored at the first location because there are two sevens and remainder is 1, and three sevens in 24, and the remainder is nothing but 3. And the 23, there are again three sevens of them. That is, the quotient is 3, the remainder is 2. So that the remainder is identified as its location into which the 23 is stored. And go to the last value is nothing but 28. There is four sevens are there, and the remainder is 0, so that we have to go for 0th location to store the information 28. But already there is a information. If try to store the 28, the data available in the same location will be deleted. So inconsistency occurs, corruptions will occur, so that this situation is known as collision in hashing technique. Okay, how to avoid such type of collisions in hashing technique? So here the four commonly used collision handling mechanism I have given is nothing but the first one is chaining method, another one is linear probing method, the third one is double hashing method, and rehashing method. Now we are going to see about the rehashing method to avoid the collision in hashing mechanism. Okay. Before see about the rehashing, we have to look on to the load factor of the hashing mechanism. Here the load factor is nothing but the ratio between the hash table size and the element size is known as load factor. The load factor will be the value from 0 to 1, and always we have to maintain the load factor from 0.5 to 0.75, because if it is greater than 0.75, the collision will occur. Suppose if it is lesser than 0.5, the memory space will be wasted. So that always it has to be maintained the load factor from 0.5 to and 0.75. Okay, so how to calculate the load factor of the hash table? We'll see by example. The formula used to identify the load factor is nothing but size of the elements and size of the table divided by size of the table. That is the ratio between the elements and the size of table. Okay. So size of the table is referred as capacity also, and the element size just specified as its size. Okay. For example, if a hash table contains 100 elements and its capacity is 200 slots, that is, the table size is 200, but only there is 100 elements are stored into the table, means what is the load factor? Is nothing but the size divided by capacity is equal to load factor, is nothing but 100 by 200 is 0.5. Okay, so always we have to maintain the efficient load factor. This is one of the efficient load factor. Okay, so as told, the efficient or ideal load factor should be between 0.5 to 0.75. Okay, so how to maintain this efficient load factor or ideal load factor by the help of the rehashing functions when collision occurs. So how do you know when the collision will occur? Is nothing but at the starting point of computing the hashing function itself, each and every data inserting into the hash table from the first data onwards, we have to find out the load factor. If it is between the 0.5 to 0.75, there is no problem. As usual, we can store the data into the hash table. Otherwise, suppose if it is greater than 0.75, there may be a collision occurs. Okay, on that scenario, we have to do the rehashing the technology. Okay, so the high load factor is nothing but the load factor is greater than 0.75 is known as high load factor. To avoid the high load factor, there are two ways are there. The one is while choosing the hash function itself, yeah, as a good hash function you have to choose. And the table size also we have to fix it in efficient way. The another solution is nothing but rehashing. Rehashing. What do you mean by rehashing? Rehashing is nothing but while collision occurs, we have to create a new extended hash table, that is resized hash table, and reload by using another hash function, reloading the data into the new hash table by using re function. Hash function is known as remapping. Remapping the elements to the new hash table. That new hash table should be larger than the old one. On that time, the load factor can be maintained an efficient manner. How it is done will be seen in this next topic, rehashing. So already I told the rehashing is the process of resizing the hash table. When we have to do the rehashing? When collision occurs or before the collision occurs, when it seems to occur the collision, on that time itself we have to do the rehashing. So how it is identified is nothing but while starting time onwards we have to apply the formula of load factor. Okay, before insert each and every data, we have to identify the load factor, and if it is ideal, then we have to insert. Such a way we have to start the rehashing function. Okay. If once if it is collision occurs, then we have to do the rehashing function exactly. How is nothing but first we have to resize the table hash table and create a new hash function, apply the hash function on each and every element is known as remapping, and find out the locations of the new table into which each and every element to be stored. Okay, so each and every time of the insertion of element, the load factor is varied and increased. If it is in once increased greater than 7.75, we have to do the rehashing. While do the rehashing, the time complexity will also be increased from order of 1 to n. Especially the hashing system is used to fast lookup, that is the time complexity, that is an average time complexity is order of 1. At the first time of hashing function itself, we can identify the location of the data so that its time complexity, that is an average time complexity of the hashing technique is order of 1. But while before rehashing, all the hashing technology and searching locations are doing once again for all the elements so that its time complexity is known as order of n. Okay. So how do you implement the rehashing technique? Already I told you the starting time onwards we have to find the index and apply the hash function. To find the index we have to apply the hash function, store the key value. So before store the key value, also check the load factor. If it is less than 0.75, we have to insert to the corresponding table slot. Otherwise, that is, the load factor is greater than or equal to 0.75, it means there is a collision. So apply the hashing technique. Repeatedly, you have to do the same steps until the last element to be inserted. Okay. An example I have given here for rehashing technique. Okay. In this example, we are trying to insert 6 data as 7, 13, 15, 24, 23, 28. So that how do you insert? By applying hash function, normal division method, by key modulo array size. Here, first time I have fixed the array size as 7. The data value to be inserted as 7, 13, 15, 24, 23, 28. So first time the value 7 is divided by 7 because the table size is also 7. Its modulo value is 0. So first value is placed into, that is stored into the 0th position of the hash table. The next value is nothing but 30 divided by 7 is nothing but its modulo is 6, so that the 13 is stored into 6th position and the 15 is stored into 1st position and 24 is stored into 3rd position, 23 at 2nd. Again, the 28 receive the same value of 0 as its modulo, that is 28 modulo 7. There are 4 sevens are there. 4 sevens are there in 28. The modulo is 0, so that the collision occurs while try to insert this. Okay. And how do you calculate the load factor? By the way, while inserting 7 into the place of 7 into the place of 0th position. First time onwards we have to find out the load factor is nothing but the element size divided by hash table size. First time the element size is 1, table size is 7. So its value is 0.14, which is lesser than 0.75. So which is an ideal load factor. We can insert the value 7. Similarly, second element. While inserting the second element, the load factor is nothing but 0.28, which is also lesser than 0.75. So we can insert the value, second value, 13 can be inserted. Similarly, third value, while inserting 15, its position is 1 and its load factor totally 3. The third value we are going to be placed and total size of the and that is table size is 7. So 3 by 7 its value is 0.42. So ideal one. So we insert the value 15 at the position 1. Similarly, 24 is the fourth value. So here the modulo is 3. That is the third position. We are going to insert the 24. The fourth element, so that 4 by 7 is the load factor, which is also lesser than 75. Without any problem, we can store the 24 at the position 3 and 23 at 2 because the load factor is 0.71 lesser than 75. And the last one, Even though it's shown at the same position, the load factor also increased. That is the great load factor is nothing but 0.8. Why? This is the sixth element divided by size of the table. Its value is 0.85, which is greater than the ideal load factor, and also collision occurs. So even though there is no collision occurs, the load factor is greater than 0.75, we definitely apply the rehashing. Okay, so rehashing is nothing but enlarge the size of the array from 7 to. In this example, I have increased the size of the table from 7 to 17. Size of the array from 7 to 17. 0 to 16 is 17. Okay, and by applying the same division function on this table size 17, we are going to store each and every data, and each and every data insertion we have to calculate the load factor at last. At the end of the last value, the load factors are below 0.75, so that all the values are placed into the enlarger table. But in one place a collision occurs. How do you avoid this? We'll see in this example. While inserting 7, that is 7 divided by 70 is nothing but the remainder value is 7. So at seventh position, the value 7 to be stored. 13 divided by 17, so there is 0 17 in 13, so that the remainder is 13. So here the second value is stored. Similarly, 15 also lesser than 17, which is stored here. 24, in which the remainder 117, another 7 is the remainder. So at seventh position, and then 24 is stored. Mm. The position 7, in which the value 24 has to be stored, but already a value 7 is there in this position. So here the collision occurred, but the load factor while doing the calculation for the data 24, the load factor is 0.23, which is lesser than 0.75. So this is ideal load factor. Even though collision occurs, the load factor is ideal. So just we are trying to apply the linear probing technique to find the next empty position location to store this 24. So probe means nothing but searching from this place to next empty space is nothing but eighth position. Here we have stored the value 24 and the next one 23. So 23 divided by 17, 117 is there. The modulo is 16. So that, sorry, modulo is 6. So that in sixth position the 23 is stored. 28 is the next one. So 28 divided by 17. So which is how many 17s are there? Here 117 is there, and its remainder is 11. So that the 11th position, in 11th position the value 28 to be stored. Okay, but for this value only in the previous smaller table the collision occurred, but here there is no collision. and load factor also ideal. So 28 modulo 70 and load factor is 0.35, which is lesser than 0.75, so that we can store this last data without collision in ideal load factor. This is an efficient way of storing the given elements by using rehashing concept with the help of load factor technique. That's it. Thank you.